Hi everyone. For today's lesson, we mainly have two things to do. One is to go through your homework, which is the answers to question D, E, and F. And secondly is to let you have the time to complete your work for today, which is a set of worksheet, which is one worksheet over here, and you can find this in your Google Classroom. Okay, so let's start. Just some feedback on what I saw from those people who submitted. It's not very well done. And what's the reason for that? It's mainly three things. One, some people still had issues with writing the chemical formula. So once you get the chemical formula wrong, you would never get a balanced chemical equation. Secondly, some people had issues with balancing the equation. And thirdly, some people forgot to write down the state symbols for your equation. So this type of question, if let's say it is 1 mark each, if you have one error, it will mean that the whole thing will be wrong. That's why there's really no shortcut around balancing equations and writing equations, and you just have to keep doing more to get better. Okay, so let's just start with the very first one. Question D. Okay, so let us run through. I have solid calcium nitrate. So this is Ca2 plus and nitrate ion, which gives me Ca bracket NO3 close bracket 2. Solid, so bracket S. Decomposes on heating, a thermal decomposition reaction, and I get calcium oxide from Ca2 plus and O2 minus. This is solid lumps plus nitrogen dioxide, okay, with the prefix covalent compound plus oxygen gas, O2, diatomic molecule. Okay, so let's start with the most complicated formula, CaNO3, 2. Okay, so looking at it, I've got two nitrate here. So to balance up the number of nitrogen, I'll look at NO2. Right, this means that I have to put a 2 in front here to balance the number of nitrogen. And let us just take a look at the number of oxygen. Okay, for oxygen, I have 3 times 2 over here, which gives me 6. For the number of nitrogen on the right hand side, I have 1 here plus 4 plus 2. So I have 7 over here, which means the equation is still not balanced. This means that one set of calcium nitrate is not sufficient. I need to try with 2. So once I try with 2, let us update our numbers. With 2 calcium nitrate, it will mean that I will need to have 2 sets of calcium oxide to balance out the number of calcium. Okay, and for nitrate ion here, now I will have 4 sets of nitrate ion. So to balance out the number of nitrogen, I will need to have 4 over here. Okay, and then let us check the number of oxygen. So let's see. For the number of oxygen, okay, let me rewrite that in. For the number of oxygen, I would need, over here I will have 3 times 2 times another 2 for the coefficient 2 in front. So this makes me have a total of 12. Right, and for oxygen here, I have, let me just close this. Okay, for oxygen here, I have 2 plus 4 times 2, which gives me 8. Right, which gives me 8 plus, if I've got one oxygen molecule here, that means I'll have 2. So this is 2 plus 8 plus 2, which gives me 12. And therefore, I have a balanced equation, which is 2 calcium nitrate solid, arrow 2 calcium oxide solid plus 4 nitrogen dioxide gas plus uh, 1 oxygen molecule. Okay, so this is my answer. Okay, let us move on to E. For E, I have calcium carbonate powder, right? So this is Ca2 plus and CO3 2 minus. That's right. The formula is as such. It reacts with phosphoric acid. Phosphoric acid is H plus with phosphate ion, right? Acids always have hydrogen ions. So the formula is H3PO4 bracket AQ, right? Because the word solution. Arrow to produce solid calcium phosphate. So Ca2 plus PO4 3 minus giving me Ca3 bracket PO4 close bracket 2, okay, plus this is solid, here solid, plus carbon dioxide gas plus water. Okay, so let us balance our equation. Our most complicated formula here is calcium phosphate, and also looking across the equation, phosphate ion appears on the left and also on the right. So for this type of equation, you can just balance the phosphate ion as a set. Okay, and you don't have to break up the phosphorus and oxygen separately. This is easier to balance it as a set. Right, so I've got two phosphate ion here, which means that I need to have a 2 over here to balance phosphate. I've got 3 calcium here, so I need to have 3 over here to balance calcium. So let us look at the of um, number of carbon. Okay, so since I've got 3 calcium carbonate already, I've got 3 carbon. So to balance up carbon, it will be over here. I need to have a 3. And lastly, for hydrogen, I've got 6 hydrogen here because it's 2 times 3, 6. So to get 6, I will need to put a 3 over here to get 6 hydrogen. So with that, let us check our number of oxygen. Okay, number of oxygen. For oxygen, it is 3 times 3, okay, which gives me 9 over here. And for oxygen here, I'm just going to ignore because I've already accounted for the oxygen in phosphate ion and phosphate ion here. So similarly, this one I ignore. So on this side of the equation, how many oxygen do I have? For carbon dioxide, I've got 3 times 2, which gives me 6, right? And in water, I have 3. So this gives me 9. So 6 plus 3 gives me 9. And hence my equation is balanced. 3 calcium carbonate solid plus 2 phosphoric acid equals arrow calcium phosphate solid plus 3 carbon dioxide gas plus 3 H2O bracket liquid. So this is my balanced equation. Lastly, two solutions of ammonium nitrate. Ammonium ion is NH4 plus, NO3 minus. Okay, so that is NH4, NO3. This is a solution, which means it's aqueous, plus calcium hydroxide, Ca2 plus, OH minus. So this is Ca bracket OH, close bracket 2. Aqueous reacts to produce calcium nitrate, Ca2 plus and O3 minus. Ca bracket NO3 close bracket 2. This is aqueous, right? Aqueous over here, plus ammonia gas, NH3G plus water, H2O liquid. So let's balance. Looking across, again, I see similar ions, right? I see nitrate ion here and nitrate ion here. So it will be good to balance it as a set. And over here, since I've got 2 nitrate ions in calcium nitrate, I'll need to put a 2 in front of ammonium nitrate. And once I put a 2 here, let's look at the number of nitrogen. Number of nitrogen here is 2. Okay, so the only time I see nitrogen is on the right hand side for ammonia. So I need to put a 2 in front to get 2 nitrogen. So let us take a look at hydrogen next. For hydrogen, I have 2 times 4, which gives me 8. And over here, from calcium hydroxide, I have 2. So I have a total of 10 hydrogen. On the right hand side, hydrogen, I get it from ammonia and from water. So I have 3 times 2, which gives me 6, plus another 2, which means I have 8. So the number of hydrogen is not balanced. And maybe let's just take a look at oxygen first as well. Oxygen, I have from over here in calcium hydroxide. Okay, I'm ignoring this O because I already balanced it in the form of nitrate ion. Right, so from calcium hydroxide, I have 2. And for the right hand side of the equation, from water, I only have 1. So it's quite clear that I will need to balance the number of oxygen. And to do that, I can increase the number of water to 2. So this means I have 2 oxygen now, and the number of hydrogen, I can update it to have, now it should be plus 4, and hence I have 10. And this, you can double check again, and I have 10 hydrogen on the right, 10 hydrogen on the left, 2 oxygen on the right, 2 oxygen on the left, and the number of nitrogen is balanced also. So this is my complete equation. I have 2 ammonium nitrate plus 1 calcium hydroxide, arrow 1 calcium nitrate plus 2 ammonia plus 2 water. So this is my balanced equation. All right, please do your corrections. And for the rest of the time, can you please complete the chemical equations worksheet? At the end of it, it is important that you submit it in PDF format. The instructions for submitting it in PDF format is already included in the Google Classroom. So just write your answers on foolscap paper, but you have to submit it in terms of PDF format for me to be able to annotate on it directly and then return to you directly. Okay, so spend the remaining time doing that. And for those of you who still owe me work since the last week, can you please do it now? All right, and yeah, thank you. Bye.